What's happening, folks? Geologist Philip Prince. Going to do another Helene video here today. Going to talk about Chimney Rock this time. Right here in the middle of the screen is the Hickory Nut Gorge, and the lighter colors you see down there are what used to be the town or the village of Chimney Rock. This place would look different now. If we had new Google Earth imagery today, you would see a very different pattern down there in the bottom of the gorge. And I want to talk about why the flooding was so bad here. And to do that, I'm going to use a digital elevation model. That's the colorful map that just appeared there on the screen. I've laid that over Google Earth. And what this map does is essentially color code the landscape by elevation. So you can see where the high points are very easily. You can see where the low points are, where the rivers and streams are, and it gives you a sense of actually where the water is going to drain when it falls onto the landscape. And that's a big part of understanding what happened in Chimney Rock, because a pretty big area feeds a lot of water into the pretty restricted bottom of Hickory Nut Gorge here, where the Chimney Rock Village itself was located. Bat Cave, North Carolina, right up here, just upstream. Girton, North Carolina, is almost up here at sort of the top of, or one of the tops, I guess you'd say, of the river system that was actually feeding water down there past Chimney Rock and ultimately down into Lake Lure. So what we're going to do here is take a look at this landscape. First of all, talk about what produced the very, very extreme rain for days leading up to Helene, and then with Helene's passage itself, and then talk about really how these river systems are laid out here, and how such a large area with so many high points in it ended up pouring all of that water down onto Chimney Rock. But the value of having a map like this when you're thinking about a landscape and how that landscape might behave is that this thing just shows you where places are higher, lower, what the relative elevation is, and in some cases, if you have a good scale bar associated with it, it can tell you actually to the number what those elevations are. I'm not using that here. This is just an overlay image. But when you look out across here, you can see that there is a lighter color side and then a darker colored side. Lighter colored side, this is the Piedmont of the Appalachians. This would be down in Polk County, North Carolina. The hand right there roughly on top of Lake Adger. So the Green River, which also experienced incredibly destructive flooding, was pouring all of its water out here into Lake Adger. This landscape, 1,000 feet, 1,100 feet above sea level, maybe 12 or 1,300 feet in some locations. For folks watching outside the U.S., 350, 400 meters above sea level, something like that. If you come up here to what would be the north, we're looking southwest here now. You come up the Blue Ridge Escarpment, which is the step between this lower elevation Piedmont and the higher elevation Blue Ridge. You're going to end up on a landscape up here that's about 2,000 feet, 2,100 feet above sea level, with high points on it here. They're up to about 4,000 feet above sea level, or a little bit more. So that would be 600 1,250 meters, something like that. The hand right now is right on top of Edneyville, North Carolina, and that is a pretty good representative location for what a lot of this Blue Ridge Plateau or upland looks like in this area. But it's notably higher than the Piedmont, and it's that step in elevation here that's very significant, because that step in elevation, if weather is coming out of the south, will cause air masses that may be very moisture laden, as they were in the days leading up to Helene, and of course with Helene itself, cause those air masses to have to kind of rise up onto that Blue Ridge surface, right? And that rising moves those air masses up into lower pressure. They expand and cool, and it wrings even more precipitation out of them. This is the concept of orographic lifting. You may have heard that in the news. It's not a term that was probably on a lot of people's minds before this, but that's the essence of the extreme rainfall here. Okay, that upslope movement. So with the weather coming out of the south, running up the Blue Ridge Escarpment like that, that's going to force really heavy rainfall, right? And you're going to see that throughout the affected area. I was going to do a video about that, looking at the region in its entirety. But really, anywhere you go with this story, that's going to be something that has to be considered. Okay, so Hickory Nut Gorge here, again with Chimney Rock in it, Bat Cave right up here. Girton would be just off the screen to the right. This is in an area that would have had that very extreme rainfall from being pushed up the Blue Ridge, falling on it, and all of that water. And when we say all of that water, we're talking about over the course of the event in places here, certainly 30 plus inches of rain, if not more. Nobody knows exactly how much might have fallen on some of these areas, and in particular the ones that are of real interest. I'll actually spin that around real quick one more time here. Keeping that idea of the orographic lifting in mind, you would want to point out that a lot of these big south-facing slopes, like you'd see up here around Girton as an example, those might have been receiving that really extreme orographic effect where the air is getting pushed up even higher across that topography, right? So you might have wrung even more rain out in some of these areas, but all of that again is going to ultimately end up draining down through the Hickory Nut Gorge and down past Chimney Rock. All right. So when we look out over the landscape now, you see all these high spaces. Chimney Rock down there, Bat Cave there. This is Swannanoa up here towards the top of the screen, and these are the Swannanoa Mountains. When we get a little bit further along in the video, I'm actually going to draw out where the drainage divide runs that controls the water that went down to Chimney Rock, and it's actually something pretty remarkable to look at. Now, in terms of understanding why the landscape is shaped like this here, why this gorge is here, why the gorge has this interesting shape. If you look at the Hickory Nut Gorge from the top, it actually very distinctly has almost a perfect cross shape like that. That was actually going to be a YouTube video on this channel before this event. Why is this gorge shaped like a cross? Obviously, things changed a little bit in terms of what I'm trying to communicate on this channel, but that shape and the processes that formed it actually ended up being contributors to why the flood event here that past Chimney Rock was so incredibly destructive. So we'll tilt the landscape again here, look out across it. And what I'm going to try to illustrate here in paint is why this gorge looks like this and why so much of this elevated Blue Ridge Plateau in these darker colors drained its water out through this Hickory Nut Gorge, right? So we're going to hop out here to paint, get it all sketched out, and then we'll come back here and talk a little bit more about these maps. Hang on just a minute. Okay, so a big part of understanding just why so much water went out of the Hickory Nut Gorge during this event is to understand some of the geologic history of the gorge itself. And to do that, I'm going to sketch out a view across the Blue Ridge Escarpment out onto the Blue Ridge Upland and try to give you a sense of some of the geologic change that produced that gorge and actually made it look like it does today. And the first thing we're going to do here is start sketching in that rough Blue Ridge Escarpment. I'm going to do this a little bit differently than I did the topography for the debris flow video, and that's because we're talking about a bigger area this time, and we're really focused on the rivers more than some of the details of the shapes of the landscape. But fundamentally, we got to capture the fact that there is a lot of topographic relief here, and you have these sort of intricate drainage networks and river systems that are connecting the various places to lower elevations, whether that be away from you out there on the Blue Ridge Upland going to the Gulf of Mexico or towards you out of the screen going to the Atlantic Ocean. And slowly but surely, I'm going to kind of build up some higher mountain ranges here back on the Blue Ridge. And these are going to end up being a pretty big part of our story here, because these are the higher elevations that are up on the Blue Ridge surface that are really good at catching those air masses coming out of the south and forcing them to generate really extreme precipitation. Coming in here with the Swannanoa Mountains now at this point, and this is what's going to be separating places like and again, what's called the overall Garin Creek community, but those places like the Flat Creek Valley where the big debris flows occurred from Swannanoa and Black Mountain, which drain all their water to the French Broad River. And the last little bit of topography going in here, way back in the distance, these are actually the highest mountains in the diagram here. That's up above Swannanoa and Black Mountain with the Blue Ridge Parkway on top of it. But again, that's out of the river system that we're talking about at this point, right? So we're in the geologic past at this point, but how far in the past, I really can't tell you, and nobody else can. Much of the landscape looks like it does today, but there's some fundamental differences, and one of those big differences that really everything up here on this Blue Ridge upland surface is going to be draining out into the French Broad River and the Gulf of Mexico, which is going to be over that way. All right, so we're going to fill in just a few more little lines here. And big distinction here, and of course, one that is still active today and a big part of this story, is that coming towards us, got a stream that's flowing down off of the Blue Ridge, across the escarpment, and actually into the Atlantic Ocean. Okay, so there's a continental divide between that little stream coming out of the screen to the foreground and the lighter blue up there on the surface. And I'm using these different colors because that's going to be a way to distinguish between these two stream systems. All right, so little stream coming out to the foreground, because it's steep and descends the escarpment, it's going to do a really good job of eroding very quickly. And again, this is over geologic time. This is sort of bigger picture thinking than we're about to talk about from the standpoint of time. And it's actually going to erode its way into this river up here on the upland surface. Well, it's kind of interesting. What's going to happen there? Well, when those lower elevation valleys coming out to the Atlantic intersect that elevated river system, it's going to capture it. And we use the term stream capture or stream piracy for this process. When that happens, that stream up there on the upland, it's going to become part of the Atlantic drainage basin, and all of its water is going to be coming out towards us. Okay, so when that happens, that little steep stream coming down the escarpment has a lot more water. It's going to erode even more quickly, and it's going to start excavating out a really big gorge. And at this point, I'm going to have to start making some major changes here to the landscape. And so we're going to even quite a little bit of that out, so we can almost rewrite the topography to a certain extent. Now, that's not going to be completely necessary because those existing stream networks are still going to control how the landscape changes here, but we're going to have to make it look quite a bit different than where we started out. And if you remember that unique cross-shaped gorge that we talked about, this is where it's forming. Okay. And if you run this far enough into the future, quite a bit of this stream network is going to have a chance to start cutting down into the landscape, have all kinds of intricate little valleys with steep sides, a lot of really cool waterfalls, and ultimately, a landscape that's just a really interesting, dynamic place to be. It has incredible views. You look up and see the mountains and the cliffs. It's an awesome place to want to spend time, as people do, right? And again, the origin of all that really dramatic topography is that stream capture process that we just kind of highlighted here. Okay, so let's start cleaning this up a little bit. We've run to the present day, and we got our river network set up like it is right now. Okay, so at this point, quite a bit of the landscape is now draining water out towards us. And I'm actually going to make the line coming out of the Hickory Nut Gorge a little bit heavier because it's a bigger river now. It has a huge amount of landscape draining into it. And once we darken everything in that's now part of this Atlantic system, we're going to be setting the stage for a rain event like Helene in the days before it to send vast amounts of water out of a pretty narrow gorge system. Okay, so at this point, as we're set up now, again, today, you've got this huge area funneling all of the precipitation that falls on it out of this pretty restricted gorge. And that, again, sets the stage for a very powerful scenario, right? If we zoom this in a little bit, we'll look at some details and throw some places on here. We'll try to use red there. So Girton, would be right there. Edneyville is going to be right there. That's going to be Bat Cave right at the junction, sort of in the cross there. And the debris flows that I discussed in the other video that came down to the intersection of Old Fort and Flat Creek Road, those are going to be back here coming off of the Swannanoa Mountains. And if you think about those debris flows, if you go up Flat Creek Road, the evidence of flooding there is almost impossible to believe to be at a point that's so far up in the headwaters of this stream network. So all of that water that fell on that mountain produced those debris flows, and that flooding at the very top of this river system, all of that ultimately made its way down past Chimney Rock. So when you think of this landscape, you want to think about these mountains being sort of like the catcher's mitt for the rainfall, and all of that rainfall over this really big area is being funneled out of that gorge there. Okay, so that's how this process in the geologic past that linked up a big area to a restricted gorge set us up with, first of all, a really amazing landscape to be in, but a landscape that can potentially be very dynamic. And if we came over here to the west, this may end up in another video. We added a little more detail to our map over here. We'd have some more high mountains right up here at the top of the Blue Ridge, sitting something like this. And within those mountains, you're going to have another river that flows out that direction. I use dark blue because it goes to the Atlantic. That's the Big Hungry River. That flows into the Green River. That is a major contributor to the destructive flooding that happened over there. And if we finish that diagram out, moving off of the screen, it would actually look quite a bit like what I drafted out there in the case of the Hickory Nut Gorge and Chimney Rock. So as a final thought, there is that really recognizable cross shape with Girton, Bat Cave, and Chimney Rock within it. I guess I should probably label Chimney Rock itself there. That's the shape. That's the process that formed it. And when we hit the maps here, keep that in mind when you're looking at them. Okay, so we'll hop back to the maps now. Okay, so hopefully with that sketch, you have an idea now how an existing river system up on the Blue Ridge got linked up to the Atlantic river systems and ultimately ended up being sort of funneled out of this gorge, right? So what that gives you is a large elevated area with a bunch of stream mileage with a lot of high peaks in the headwaters of those streams draining out through a sort of an unusually tight and constricted gorge landscape. When you pull all the water out of the clouds through the orographic lifting for days and then have that big punch from Helene itself moving in the same direction, all that water comes through that confined space, and that's how you're going to end up with a flooding event that goes to a scale that is really something we didn't even sort of think about before this event happened. So what does this river system actually look like on the map here? I'm going to do my best to draw this out. Sometimes it's kind of hard to see exactly where you're drawing on the screen here, but I'm going to be using these colors and the elevation information that they're giving me to actually kind of draft out this drainage divide. And the reason I'm cutting across the gorge there is I'm trying to show sort of the big contributors to the flood that would have pushed the water down into the gorge, essentially from a little bit below Bat Cave and down. Right in this area here, that's not going to be contributing significantly in terms of water going to Chimney Rock, and we'll actually mark Chimney Rock Village's location just like that. Okay, so we'll keep going here. Really sort of an interesting and complex pattern. Not going to be absolutely perfect here, but going to be close enough. I actually just drew right there. That's coming around the top of Garin Creek. Garin Creek itself actually goes to the French Broad River, but Flat Creek, where the debris flows happened, that actually drains its water, believe it or not, to Chimney Rock. And I'm going to mark right now where those big debris flows I talked about in the other video actually occurred. I have to use a different color there. Okay, so up here towards the top of the screen is where those big debris flows came down to Flat Creek Road, Old Fort Road area. And if we start drawing streamlines in here now, we'll try to just give you a sense of what this network that drains down past Chimney Rock actually looks like. And it's just remarkably extensive. Sort of a thing that you wouldn't maybe you wouldn't notice or think about at a glance if you looked at a map of this area. But suffice it to say, a huge amount of elevated mountain landscape is sending its water downhill and down past Chimney Rock, down into Lake Lure there at the bottom of the screen. Now, what's this going to look like if we fade that colored elevation map away? You're going to end up looking something like that, right? So a big piece of this landscape was funneling 25, 30, maybe more inches of cumulative rainfall over those days out through that pretty restricted gorge. And that's going to produce a destructive flood. Now, things like this have happened in the past. 1916's flood was extremely destructive in the Hickory Nut Gorge. No one really knows how you could compare that directly to what happened here because there'd been construction in the gorge, development, the landscape had been modified along the river. But regardless, what happened here with Helene is a massive, incredible, historic event. It seems hard to conceive that you would see that repeated for a very long period of time, but we simply don't know that. And when you think about those terms, it may be worthwhile to consider possible future events in terms of how planning is done in this area. We're going to clear that off of there. I'm actually going to zoom in now on the gorge itself and look at some of the satellite imagery that came out after this event, just to give a sense of how things have changed in here. You can see here with Google Earth, got the river right there, buildings, and the highway here, 74, running up that gorge. And if we bring in some of the new satellite imagery there, the whole area has been just sort of wiped clean. And you've seen those images. They're dramatic, almost unbelievable if if you've spent time in this place at any point. I mean, even just driving through, it's a remarkable spot. The landscape's absolutely incredible. But that incredible topography is the result of it being, a really dynamic spot in the Appalachians. And what we've seen here is just one of the steps that's gone into sculpting this landscape into what you see today. See big debris flows here coming down the slopes. This one would have crossed the road if the road were still there when it came down. I don't know if that was the case. I don't know what the impacts of this one might have been, but it obviously came all the way down to the river. And if we pull that satellite imagery out yet again, you can see that there's a lot of structures down there that just they don't exist anymore. Their debris it's in Lake Lure at this point. Some particular spots of the river down here got really extreme erosive damage just because of the way the river is bending here. The flow is kind of running straight into the side of the mountain here. And if we pull that imagery away, you can see just how much of the road and the slope actually going down to the river from the road has been changed there. So when construction continues and starts pushing this road back up through the gorge, it's going to be something to think about in terms of just keeping it stable. The river is probably going to be in sort of an unstable condition as it tries to settle back down a little bit after this flooding event, and there's going to have to be a lot of fill material introduced just to make it work again. So a lot of things to think about here. But if you bring in Lidar imagery of what this landscape looks like, you get the impression it's rough. Obviously, that's what attracts people to it. It's very beautiful, rugged, rocky, a dramatic place to be, particularly if you come up out of the Piedmont to see it. But that ruggedness again is kind of an expression of its geologic history. And the lidar imagery we're showing here is from about 2017. You can see the highway coming down here along the river. There's the river itself actually has boulders down there in it that you can see. If you got lidar of this gorge today, it would look dramatically different. And when you look up at the cliffs here, I mean it's one of the most rugged landscapes really in southern Appalachia. The Blue Ridge Escarpment has a few places on it like this. This one stands out because of the shape of the gorge, but it's rough. It's rough country. And when you have slopes like that, cliffs like that, material piling up that's fallen off the cliffs but have stayed up on the slopes, that sets the stage for events like this debris flow here. And we can actually use LiDAR there to see that the debris flow started up here in the cliffs, came down through this little sort of channel here, and would have again crossed the road if the road was still intact at the time that it happened. So keeping this in mind, this is always going to be a place that's going to be a challenge to some extent to work with when weather events like this occur, and weather events like this when they interact with the topography, like we've been talking about here, with the weather sort of coming up that Blue Ridge Escarpment and getting that orographic lifting process, that's when you really need to be thinking about the potential for the extreme rainfall. Now, that can happen in any direction as long as the weather has an upslope flow. That sets the stage for localized extremes. But in this case, moisture basically straight from the Gulf of Mexico went up these slopes for days, and then with that final punch from Helene, that was what really sent it over the top. Probably going to do another video or two about just what the land looks like now, but sort of an unpleasant image to look at, but one that is worth seeing is what Lake Lure looks like now. This is just a little bit of an overlay here from the satellite imagery, but up at the top of Lake Lure, there's a huge amount of debris, and everything being circled right there. That's actually that big raft of material that was washed out of the river during the flood. If we fade this away to see what the outline of Lake Lure used to look like, I was last there in late August of this year. It's different now. There's huge sandbars, gravel bars out here in the lake. The amount of sediment that came in with this flood is absolutely exceptional. And of course, all of that destroyed housing, trees that came in with debris flows, trees that were washed out by the river. That's all in the lake now. And again, nobody has seen something like this happen that's alive today. So how this is all going to be dealt with, going forward, trying to restore normalcy. That's going to be something to think about for sure. So as kind of a takeaway here, I guess the idea is that this is an awesome landscape. People love Western North Carolina. They live here for good reason. They travel here. They want to live here, and it's because of this landscape. It's because of what the land looks like. Problem is that land, when it interacts with certain weather systems in certain ways, it can produce some really exceptional outcomes that can be very dangerous to be around, and can sort of change the way you think about what's going on here. So thinking is the key word there. And again, like going forward here, it's going to be interesting to see how we handle this, and to see what happens the next time we get a really big rainfall here. Hopefully, of course, not something on the scale of what we've just seen. That's sort of an unimaginable thought, but we will have significant rain events here again during the recovery period, and I don't think anyone knows yet exactly what's going to happen there. So that remains to be seen. This landscape in general, everywhere has a story here out of this event. Up here in Swannanoa, if you've been there, if you've seen images from that, again, just unbelievable. I've driven through there a couple times. I don't even know. There's not much you can really say about it. That has a lot of really high mountains that drain water down to it. Big contributor to what happened there. Over getting into McDowell County, stepping up here from the Old Fort area up onto the Blue Ridge, you go from low elevation to very high elevation quickly. Similar type of effect, right? So probably next video or two, I'm gonna push this out to a bigger, kind of a bigger regional scale, because what we just talked about here happened in one way or another, basically all the way up to Boone. I'm not aware really of an event like this that's had that big of a geographic reach and did so much to people and infrastructure in the 20th century and maybe beyond. So as we keep rolling here, and all of this sort of sets in, it'll be a lot to think about. Right? So hopefully this was interesting. I hope this sort of explains some things, and hope you check out the next video here. Staying pretty busy these days, but I'll try to keep them coming.